Good morning, everyone. In today's lecture, we are going to discuss about the basic types of operational amplifier. In the previous lecture, we have discussed the basics of operational amplifier. So, there are two types of operational amplifiers. One is inverting operational amplifier and another one is non-inverting operational amplifier. This classification is based on the two input terminals of the operational amplifier. So, considering the inverting operational amplifier. So, see, this is the operational amplifier, and if I give the input to the inverting terminal, this is the inverting terminal, that is the negative terminal, and this is the positive terminal. If I give the input to the inverting terminal, then we call it as an inverting amplifier. So, the V1 input is being given to the inverting terminal, and the other terminal, the non-inverting terminal, is being grounded, and this is the input resistance and this is the feedback resistance. Right? See, if you do not have a feedback resistance, then we call it as an open loop operational amplifier, and the gain relevant to that is open loop gain. Here we are discussing about the closed loop operational amplifiers, and here the gain will be closed loop gain, which is a finite value. So, RF is the feedback and resistors. So, if you see, in order to calculate the relationship between input and output, we are going to consider the nodal equation. So, if I consider this point, I am naming the point as A. If I consider this point, here see two currents enter into this terminal A. One is current I1 across the resistor R, and another one is current IF across the resistor RF, feedback resistor. And now when I apply the nodal equation, the things which we need to remember is the operational amplifier input terminals do not consume any input current, do not has any input current. So the input current at this terminal will be 0, and so see here this inverting terminal is grounded. So at this terminal the potential is 0, and obviously at this point the potential will be 0. Right? So at this terminal, because of this the potential will be 0, then only the potential difference between the two terminals also will become 0. So considering that condition, see, this is incoming current to this junction, and this is also an incoming current to this junction. So by applying the nodal equations, at this point when I calculate the current, that is V1 minus VA divided by the resistor, that is, this is equal to I1, which is V1 minus VA divided by the resistor R1, and the other current is V out, which is represented as V0, and V0 minus the same terminal divided by the resistor. That is, these two are the incoming currents, right, which is equal to 0. And as I said, since these two are internally connected, it do not consume any current, and so at this terminal, since the voltage is 0, this terminal also will be having the potential 0. So I am substituting VA is equal to 0. Wherever we have VA, it is equal to 0. So V1 by R1, this becomes 0. Here also V0 by RF will become 0. So from this we have to, now our aim is to find the input-output relation. Input is V1, output is V0. So from this V0 is equal to minus RF by R1 into V1. And see, this RF by R1 is known as the gain of the amplifier. Gain of the amplifier. Right? So if it is an inverting operational amplifier, the output will be minus A into the input voltage. This minus denotes that whatever input voltage is being given, suppose if my input voltage is like this, right, 1 clock cycle, if this is my input voltage, then my output voltage will be 180 degree phase shifted value of this input voltage. That is why we get a minus sign. This will be P out with respect to time. So this is the input. If this is the input voltage, this is the output voltage with respect to this equation. Because of this inversion, we call this amplifier as an inverting amplifier. Now coming to the non-inverting amplifier. In the case of non-inverting amplifier, we give the input to the non-inverting terminal, and this terminal, the inverting terminal, will be grounded. Here obviously we will be having the resistor R in, and here this right? And here it was grounded. So we know that the flow will be from the higher potential to the lower potential, and so the current flow will be in this direction. So see, here it is I1 in this direction, here we have IF as usual. So this is equal to this current entering into the circuit will be at a node will be equal to the current leaving the particular node. So this is the current relevant to this RF potential V0 minus I have written V1 because at this potential at this node A the value is equal to V1 divided by the resistance R, and here this V1 minus here it is ground potential 0 divided by R. Simplifying this, we will be getting finding the relation V0 is equal to V1 into 1 plus RF by R1. Just merely we substitute the values. We separate V1 to this side and taking the common terms. And here for this, this is known as V1 into, this is the gain here. So V0 output voltage for a non-inverting terminal is V input voltage into the gain. So here see, if I have an input voltage like this, then obviously my output voltage also will be the same without any. So if this is V0, input voltage V1, then this will be V0. No phase shift will be here in this case, and that is why it is known as a non-inverting operational amplifier. So in an inverting operational amplifier, there will be 180-degree phase shift, and in a non-inverting operational amplifier, phase shift will be 0 degrees. Thank you.